So continuing on with our domain and range lesson, I think we got right to here, but we were skipping domain and range. So can we go to the very, very, very beginning right here? Okay? Remember this graph that we drew? It looks like this. First of all, is it a function or not? Yes, it is. The domain is all of the x values that get used up. How far left does that graph go? Now you'll notice it has arrows on it. So how far left does that graph go? It's got arrows on it. How far left does it go? I'm looking for a word rather than a number. Yeah. What do we call that? It begins with the letter I. You know what? It goes to negative infinity. It does. You know how I can tell? Because there's arrows. How far right does that graph go? Positive infinity. So if we were talking about the domain, we could say the symbol for infinity is an 8 on its side. This is the symbol for infinity. We could say between negative infinity and positive infinity. Nah, too much writing. We're going to write that down, but too much writing. We're going to give that situation a special name. We say that this is all reals, or all real numbers. You want the domain of that graph? It's all reals. It goes from negative infinity to positive infinity. And we have a really, really short way to write that because even all reals is too much writing. We're going to say all reals. I'm not going to write all reals. We're going to write it as follows. Because it's domain, we're going to use the letter X. There is a symbol for is a part of or belongs to or uses up. And it's a capital letter C with a line in the middle. It's sort of like a curly capital letter E. And the symbol for the real numbers is a capital R. You read that as all reals. You write it as X, funky letter E, curly letter E, R. That's the domain of that graph. What's the range? Well, again, this graph has arrows. How low does it go? Doesn't it go past? It's got arrows. How low does it go? I heard it. Who said it? Someone said it. Negative what? Negative infinity. Doesn't it? Doesn't it keep going down and 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 down forever? How high does it go? Angela? Positive infinity. This graph has a range, and it's, sorry we're starting off with a bit of a tricky one, but it's the first one. This graph has a range of everything. You know what? This graph has a range. Same thing. Which we would also say was all reals. But we would not write XER because it's the range. Which variable is the range talking about? The X variable? No. If it's a continuous graph, I have to give the domain and the range in terms of what it uses up, what's it between, what it's between. That's a yucky one to start out with. Turn the page. Okay. We did this one, and this one they gave us the domain in the question. They said D equals 1496 and R equals 1234. So let's look here. Example 2. When you have points, it's a little easier to find the domain and range. Let's look at A. We all found where we are? What's the domain of this first graph? It's all of the x values that are used up. There are only 3 x values that are used up. You there, Curtis? Figure out where we are? Right? You all turn the page and then turn the page again, right? We're on example 2. We're all there? The domain, if they give me a list of points, is the x values. These are the x values right here. Alon, read them to me.
1, 3, and then
That's your domain. But you know what? So all of our answers look the same. Let's put them in order from smallest to biggest. What's the smallest domain value? Comma. What's the next one?
1.
Comma. What's the next one? And it's traditional when you're listing the domain to use the funky curly set notation brackets like that. That's your domain. What's the range?
-4, 0, and 12.
Yep. -4, 0, and 12. B. What's the domain of part B? -3, -2, 1, 3, and 4. Sorry, -1, -3, -2, -1, +3, and 4. Thank you. What's the range? If I go in order, 1, 4, 9, 9 again, I'm not going to write it twice, and 16? Those are the y values that are used up by this graph. C. The domain is the x values that appear on this graph. Garrett, the x values that appear are this one, this one, this one, this one, this one, and wherever there's a dot, I read the x coordinate that goes with it. And I'm going to go from left to right, so I'm automatically going from biggest to smallest. My domain is -3, -1, 0, because there is a point on the y-axis, yes? 1, 2, and 3. What's my range? What are the y values that appear on this graph? -2, -1, 0, and 1. Greg, you see how we're getting that? Yeah? Points isn't too bad. It's when they're connected, when they're not disjoint, when they're not discrete. When they are discrete, when they are discrete, when they're not continuous. I said when they're not discrete. When they are discrete, it's easier. Just read out the x values. Here, domain, -2, -1, and 2. Range. Brody, what's the range here, kiddo? Here's the lowest y value. What y value is that? That's going to be in the range. -2. Keep going. Keep going. Keep going. You do know. You were just zoning out, mister. You back? Woo! So if they give you points, Simi, list the x's, smallest to biggest, please. List the y's, smallest to biggest, please. Don't write stuff twice. That's your domain and range when they are discrete. We're skip E. Gets a little tougher when they're connected, like this third graph, the circle, and this fourth graph. So let's look at this graph here, this bottom page one. It says, ask yourself, what is the lowest and highest x value? Does this graph have arrows on it? So Alex, does it go forever? Okay. What's the lowest? What they're really talking about is the leftmost x value. And the highest, I think what they're really talking about is the rightmost x value. The domain is between those two numbers. Say what? What's the lowest x value that appears? What is it? -3? What's the highest x value that appears? 3? Does it use up every single x value in between -3 and +3? Yeah, you know how I know? It's connected. So I can't just list these all separately. I can't simply say, by commas. There's an infinite number of domain values. It's every single possible decimal value between -3 and +4. So here's how we write that. We looked at this a bit last day. We write the smallest value first. Leave a space. The x is in the middle. Leave a space. The biggest value. Sorry, 5, Mr. Dewick, not 4. What we want to say, Alon, is that x is between -3 and 5. We physically write it between -3 and 5. And then we're going to use inequalities, greater than and less than signs to fill this out. We're going to put a less than and a less than right there. Now here's what that means. If I just, don't write this down, if I just look at this, what we're saying is x is bigger than -3. X is to the right of -3. Are all my x's to the right of -3? Yeah? Check. Sam, if I just wrote this, I'd be saying x is smaller than 5. I'd be saying x is to the left of 5. I'd be saying x is to the left of 5. Are my x values to the left of 5? So if I want to say everything between -3 and +5, I say at the same time, x is bigger than -3 and smaller than -5. Yes? Ah, Brody. I was coming to that. Brody, do you notice that I filled in this black dot and I filled in that black dot? What I'm really saying there, Amber, is it touches there too. So really what I should say is x isn't just bigger than -3. It's bigger than or equal to -3. Don't write this down. X is bigger than or equal to -3. We combine these into one statement as follows. Bigger than or equal to. We add half the equal sign. We would put an or equal to right there. And that says it's touching at -3. I know, this is abstract. Is it touching at +5 too? Yeah! We would put an or equal to there. To find the range, we ask for the lowest and highest y values. And then the range is between those numbers. Symbol for range, capital R. What's the lowest this graph gets? -3. What's the highest this graph gets? Do we use every single value between -3 and +2 in terms of heights? There's no gaps. Y is between those ones. It's bigger than that one. It's smaller than that one. It touches. It touches. Next page. Looking at these four graphs, can you figure out how I will show that it doesn't touch? Specifically, look at the difference between A and B. Can you see how we decided in math to show that it doesn't touch? Hollow circles. Yeah, hollow dots. Okay, you ready? Look at graph A. First of all, the first thing it wants me to do is state the domain and range and whether or not it's a function. Let's do the function part first, because that's the vertical line test. Which of these are not function? Is A a function?
Yes.
Is B a function? Is C a function? Nope. Is D a function? No. Let's see. Is there just 4? Yeah. Let's see if we can get the domain and the range. So, domain. Graph A, how far left does it go? -3. How far right? So the domain is going to be everything between -3 and +4. Domain is X. It's always, if I write the smallest to biggest, say I'm going to be less than. The little noses of the greater than signs are always going to be pointing to the left. Is it touching, Ashley, at negative? Is this touching right here? Say no. How do I know? What did we do to show that? How do I know that this one is touching, this one is not, this one is not? How do we show it? Okay, hollow circles. So don't write this down. I'm not going to put one of those there. I'm not going to say it's touching. To do that, I just leave it there, and that tells a math nerd, you know what? It gets closer and 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 closer to -3, but it never touches. What about at +4? Is it touching? There's my domain. Range. How low does this graph get? How high does this graph get? 4 high? Looks like it has the same domain and range. Well, maybe. Let's see. It's the letter Y. Less than, less than. Is it touching at any of those? Then Brady, I'm good. Domain, all x's between -3 and +4. That's how you'd read that. Range, everything between -3 and +4. All y's between -3 and +4. B. Domain. How far left does this graph go? Sorry for you guys, it's that way. How far left does this graph go? How far right does this graph go? It's all x's between those. Alex, it's always smaller than, smaller, less than, less than. Are any of these going to be the or equal to addition? Are any of these touching? Which one? Yoink. That tells a math nerd that this graph goes as far left as -3 but doesn't touch it, and it goes as far right as +4 but does touch there, does connect there. What about the range? How low does this graph get? How high? Careful, don't say 2. Ah, the highest point isn't the end of the graph. The highest point is right here, yes? So 3, it's the letter Y. It's always less than. Are any of these touching? Which one? Yeah, I think it touches right there. If I zoom in, it looks like it does. They didn't put a dot solid in there, but I think I can assume it does touch there. Graph C. How far left does this graph go? -4? How far right? Marcus? Okay. For this one, since it's not between 2 values, it's everything to the right of -4. We write it this way. Everything, all x's, bigger than to the right of -4. Everything to the right of -4, that goes all the way up to infinity. Oh, is it touching at -4?
Yeah.
Or equal to. This is tricky. Okay. What about the range? You okay with, by the way, the domain? It's not between 2 numbers, Amber. It's everything to the right of. By the way, I am saying everything to the right of, which is in that direction. Which way is the nose of this guy pointing conveniently? Also, oh, okay. Yeah. It's a dumb way to remember, but it works. The range is the heights. Do I have arrows on the ends? How low is this graph going to go if it keeps going? As a number, if it keeps going, what did we call that as a concept? Do you remember? Began the letter I. Negative infinity. How high is it going to get if it keeps going and going and going and going? So this is between negative infinity and positive infinity. And it uses up every y value in between. What did we call that?
All reals.
All reals. How did we write that? Y, little curly e, r. D. D. Function? No. Fails the vertical line test. How far left does this graph go? So the domain, the smallest value is -4. What's the biggest value? 2. X is between them. It's going to be less than. Does it look like it touches at -4 and +2? I think so. I think so. What about the range? How low does this graph get? How high? It's the y value. It's everything between -1 and +2. Touching at -1, Sam? Yes, it is. Touching at +2, tis. There's my range. A lot of different situations. If it's a disjoint graph, Garrett, if it's points, just list the x's and list the y's. If it's connected, how far left, how far right, give the in-between. Oh, if there's only one cap value and it shoots off to infinity, then just say whether it's to the right or to the left, or if it's the range above or below that y value. For some reason, the letters kind of vanished, so let's go. This is D, is that right? Or E?
E.
E. And for some reason, F kind of vanished. I'll have to fix that. E is tricky. Or maybe I underestimate you guys. We'll find out. How far left does this graph go? You're right, whoever murmured that. How far right does this graph go? Are you saying that this is a graph that has as its domain only one value?
Yes.
In fact, this is strange because I said that for a disjoint, for a discrete graph, for a separate points graph, you would just list the number. But here, I can only just list the one domain value as well, because vertically, there is only one x value that gets used. X equals -2. What about my range, my y values? How low does this graph go? -5? Arrows? Negative infinity, because there's arrows, yes? You always got to check that. How high does this graph go? Positive infinity. This goes from negative infinity to positive infinity. Not only is it a good way to stretch out my arms, it feels great. What did we call that when it went from negative infinity to positive infinity? All reals. How did we write that? Range. Y, funky E, R. F. F is nasty. Well, let's do the domain first. Garrett, are there arrows on the end of the graphs? Okay. Let's use our imagination. Both graphs go that way when they leave the page, yes? How far will they go that way? Are there arrows? Negative infinity. How far will they go this way? Are there arrows? Positive infinity. Oh, are you saying it's between negative infinity and positive infinity? How do we write that? So we would say all reals, and we would write all reals. That's what that means. And now we enter, to be honest, Math 12. I don't think you're going to get one this tough on your provincial exam or on your test, but I like doing it. How high does this graph go? Are there arrows? Yep. And look at the bottom graph. How low does this graph go? Are there arrows?
Yes.
So it's sort of all reals, except can you see there's a little gap in the middle where no y values appear? Between -1 and +2? So the easiest way to write this is to treat the top graph as a separate graph, treat the bottom graph as a separate graph for range. The top graph, how low does it get? To touching? Yeah? And then everything above it? To write the top graph, everything bigger than or touching 2, comma. By the way, if you have trouble keeping your less thans and greater thans straight, there is that dumb alligator thing which never made sense to me. I'll be honest. That's a less than. What capital letter does that look like? L for less than? That's what I've been using since I was in grade 9. I came up with that one on my own. If you write that, read it as less than. If you write that, read it as greater than, and just keep reading from left to right. Anyhow, this is y, it's not an L, greater than, or touching -2. That's all of that. What else? Well, this graph, what's the highest this graph gets? -1 and everything below it. Yes? Touching? Everything less than, looks like a capital letter L, below -1 and touching. That's a tough one. Having said that, that graph is called a hyperbola. It shows up all over the place. Comets, when they come around the Earth, their huge orbits travel in hyperbolas. They travel in hyperbolic arcs. I believe the Portman Bridge arch was a hyperbola. I got to double check that. So they've closed it down, but that was a hyperbola. Pringles chips are hyperbolas because one of the things that three-dimensional hyperbolas have is nice stacking properties. They will stack on top of each other with no gaps in between. That's why you can fit so many Pringles chips into a can. Does that mean, Mr. Dewick, when we're eating Pringles chips, we're doing math? Yeah, it does. Okay, sorry. Domain and range. This is tricky, I know. Example 4. Let me look. You know what? Sure, let's do example 4 and then we'll press pause. It says the cost of a theater tickets depends on how many tickets you buy. Each ticket costs $12. So how much would 2 tickets cost? 3 tickets? Okay. What's the smallest possible value for the number of tickets you could buy? What's the fewest number of tickets you could buy? Even fewer than that. I think you could say, I'm not buying any. That's a valid point. Can you buy -1 tickets? So when we're talking about our domain, no negatives, right? What's the largest number of tickets you could buy? What's the theater hold? I think the largest you can buy is 550. What's your domain? I think you can buy 0 or 1 or 2 or 3 or 4 or 5 or 547, 548, or 549, or 550. Now here's the problem. Could I connect those? Can I buy 1.8 tickets? So I want to say, I want to say everything between 0 and 550. That is true. It is all the numbers. Oh, and it is touching because you can buy 0 and you can buy 550. But I want to show that this is not made up of all of the decimal numbers. We looked at number systems. We looked at whole numbers and natural numbers and rational numbers, and X belongs to integers, no decimals. That's advanced and tricky. But because we can't have 1.6 tickets, what we're saying is it is all the numbers between 0 and 550. I don't feel like listing them out, but no decimals, please. And remember, integers was not decimals. Decimals appeared when you went to the rational number system. What's the set of all the possible costs to attend the theater? What's the range? Okay. If you buy no tickets, how much?
0.
If you buy, why? If you buy 550 tickets, how much? Yep.
6,600.
You went 550 times 12?
Yep.
Problem. Can you ever pay $10? Can you ever pay $13? What's one ticket, Alex? So can you ever get charged $13? In fact, all you can ever get charged is 0, 12, 24, 36, 48. You can only go up by 12s. So I have to somehow qualify for my range that any number that doesn't have 12 go into it evenly doesn't count. That's going to be really, really tricky to write. We're going to come back to that, but I'm going to make a little note here, comma, y must be multiples of 12. Yep, yep. Okay. D, why does the domain not contain any fractions? Can you buy part of a ticket? Tickets come in chunks, in whole numbers. Okay, let's complete the table below. So 50 tickets is 50 times 12, how much? 600? 100 tickets is how much? 1,200? Are we just going up by $600 every time? Yeah? So it's going to be 1,800, 2,400, up by 3,000, up by 50 tickets again, 3,600, up by 50 tickets again, that's another $600, 4,200, 50 more tickets is going to be 4,800. What comes after 48 plus 6? 5,400, 6,000, 6,600. All right, let's graph this. Yeah. 50 tickets is 600 high. I think 600 would be, I'm going to guess, right about there, a little above 500. Yeah? 100 tickets is 1,200 high. 1,200 would be right about there, ish. 150 is 1,800, a little below 2,000. 200 tickets is 2,400, a little below 2,500. Oh, I can get 250 exactly. That's 3,000. Whew, that's definitely right there. 300 goes into 3,600. Yoink, about there, a little above 3,500. By the way, if I was doing this graph, I wouldn't go up by 500s on my scale. You know, it would be a much smarter scale to go up with on the y-axis. Go up by what? You're right, someone said it. I heard someone say it. What are our y values going up by in our data table? 600s? I'd probably go up by 600s. That'd be a better scale, but that's okay. Whoever typed this up went up by 500s. Keep going. 350 is 4,200, which is going to be yoink right about there. 4,000 is 4,800, which is going to be about there. 450, 5,400, which is going to be just below 5,500. 500, 6,000, I can get that one exactly. Woohoo! And 550, 6,600. Could I connect this as a straight line? I don't think so. Sorry. There's definitely a pattern, but I think I could only connect this as a dotted line, because if I drew a straight line, wouldn't I be saying that decimal values were allowed for ticket numbers? Right? It'd be something like that. It is linear. All right. That's a lesson on domain and range. I don't think I nailed that lesson, but okay. Your homework to try. Number 1. Number 2. You can nuke K and you can nuke L. Number 3. I'm going to skip 4, I think. Number 5. Number 7. And number 8. Okay. Now, they're writing the domain sometimes a little differently in the answers. You have to look at it a little bit. We'll talk about this next class. But for now, take-home quiz. And then try this. Also finish the homework from last day. On when I see you next, which is on Monday, I guess, because no school for you guys on Friday for some silly reason. Oh, I don't know how you earned that one. We'll do lots of domain and range practice. I have a big sheet of practice, domain and range.